Okay, 4.7, number 4. Here's a typical question. And in fact, I think I'm going to actually do today's by handing this out to you and doing, there's so many questions that instead of like having you cross off a bunch, I'll just do questions off of this as my help for you for the lesson for today. So I'm going to pause for a moment, give you this worksheet, and we'll do a bunch together as your way of learning it. It's mostly review today, thankfully. And then tomorrow is the official review for the test, which is on Thursday. All right, so I'm pausing while I hand these. Okay, here we go. Number 1. Inverse sine. Shh. Quiet, please. Let's get some done together, and then you'll have a chance to chat while you're doing your homework. In the back row, read me the problem. There you go. Thank you. Number 1. Yep. Root 3 over 2. Okay, so then my first advice would have been to rewrite. So, rewrite. Now I can tell they want an angle, right? Isn't this the same thing as you did before? Yes, this is review right now. Okay, and let's make sure in the directions they haven't thrown us some kind of a curveball. In exercises 1 through 20, which is the front of the page, evaluate each of the quantities that is defined, but do not use a calculator or tables. So in other words, they must be giving you angles you'll know, like 30s, 60s, 45s. And if a quantity is undefined, say so. When will it be undefined? When it's setting up a situation that's not possible. If the answer is an angle, answer in radians. All right, so this looks very familiar. Just make a little triangle. Why did I do it there? Well, inverse sine's only allowed from here to here, and therefore these are out. And sine's only positive, like it says right here. Sine is positive root 3 over 2. Up there, can't be there because sine wouldn't be positive, so I have to be there. And then I can say root 3 is opposite, hypotenuse is 2, that must be a 1. 60, also known as what? Pi over 3. Good. All right. Now let's go to some of the more difficult ones. Let's go down to number 12, for instance. That's a really typical problem where people think, well, just cancel those two. Let's see if that's going to have worked or not on number 12. Number 12 says cosine of inverse cosine of 4/3, I believe. Yes. So the first thing you do is start on the inside. You do not just cancel them off. You look and see if cosine of theta equals 4/3. Is that going to cause any problems? Yeah, because cosine's adjacent over hypotenuse. The hypotenuse is smaller than the adjacent. That can't be possible. Now, what if it had been like 3/3? Then would I say undefined? No, then it's one of those spots that's on the axis. It would have been one of these spots, like here. They call the quadrantals. But if you actually have the hypotenuse being smaller than another side, that's never going to happen. So bottom line is, that's why these can't just cancel. It would be wrong to say 4/3. It's instead undefined. Otherwise, no solution would have been an okay answer. Yes?
For these, if it's not undefined, but it's not one of the recognizable triangles, what would you do?
Okay, when you do get the kind, like let's say this had been a 3/3, then it would have been like this. You'd say, all right, cosine of theta equals 3/3. Then I would go and figure out where must I be? Well, 3/3 is equal to 1/1, right? Which is equal to 1. So what's cosine? Is it the x or the y? That's what you'd have to remember here. Cosine is the x. So you'd ask yourself, which of these spots has an x of 1? So this spot's 1, 0. This spot's 0, 1. This is -1, 0. And this is 0, -1. Which one of those has an x of 1? That's the one that has an x of 1. And be careful, if the directions say you can't use 2 pi, you would have to use 0. Because this is either 0 or 2 pi, but a lot of times in the directions it says that the answer has to be less than 2 pi, in which case the answer is 0. Okay, now I just changed the question. She asked, what if this had been the same? All right, moving on. Let's do another one on the front side in the denominations. All right, number 11. So, you guys don't like that idea?
11.
All right, number 11. Sine, inverse sine of 1/4. So I'd start by being in the middle and rewriting. Sine of theta equals 1/4. Is that going to cause a problem? No. So I can do that one because the hypotenuse is the big side, and that's okay. So then I figure out where can I be for inverse sine. I can't be here and I can't be here. And sine is positive, so I can't be there. That only leaves me one spot to draw this right here. And if the sine is opposite over hypotenuse, that is a possible situation. Now, do I need to know the third side for this one? No, because they're not asking me like cosine or tangent or anything. So if I don't ever need the adjacent, I don't need to go figure it out. So now I've got my triangle drawn right, and now I just have to do sine in that triangle. Sine is opposite over hypotenuse, which is 1/4. So this is one of the kind where these would have canceled, and the answer is 1/4. Good question. Now, when I'm in this problem right now, would I normally give you the angle? I would. But see, I don't need to know that angle if I'm just going to do sine of that angle, because what I really need to get sine is the sides. All right. It would have been nice. I mean, if I'd have known this was 60 degrees, I would have used that, but I didn't know what it was. So I didn't have to know what it was. Sine is a ratio of sides, so I just needed the sides to do that one. Moving on. Got any other nominations? Okay, number 15. That's the last one I'll do on the front side. I'm going to write inverse tan with a little -1, of tangent of, and what is in the middle? Thank you. -pi/7. Okay. My first thought is start in the middle. That's right there. Can I do that? Yes, I can. I can do tangent of -pi/7. First of all, where is tangent allowed? Inverse tangent is allowed in this zone right here. So I can't be here and I can't be there. Because eventually I'm going to do the inverse tangent deal on it. And where is tangent of -pi/7? Well, here's where negative goes, down that way. And pi/7, I don't exactly know how far it is, but it's something like pi/6. So there we go. I've drawn my angle. And now I need some sides for this thing. And if I'm going to do this answer, I don't even really need the sides. Just like last time, I really didn't even need the angle. Because I'm in this same triangle where this angle right there is pi/7, -pi/7 actually. So if I do inverse tan, do you get that what they are asking me for is an angle? What is the angle in question? -pi/7. Whenever it's an inverse like this, that means they have given you the side ratios and they want the angle. Whenever it's like this, not an inverse, that means they have given you the angle and you're going to figure out the sides. So, how do I know the answer for this was an angle? Because I know that this kind right here always gives me the sides and I'm supposed to tell them the angle on that kind. Anything that's normal like this has given me the angle and they want me to tell them the sides. Except tangent of pi/3 isn't that, it's √3/2. Okay, anyway, no, it's not tangent. The last one was incorrect, but the point was that if they've given me the angle, then I obviously will give them back the sides. All right, moving on. Let's go to the back side, do some of those. Any nominations?
Brackets and parentheses.
Brackets and parentheses, that mean the same thing. It's just that it's a really big function. Okay, number 29, would you read it, please? Of arc cosine, I'm going to go cosine -1 of -1/3, like that? All right, good. So I start with a rewrite, and I see if the thing is going to make sense or not. Cosine of something equals -1/3. Ooh, it's different. It's negative for once. So where is inverse cosine allowed? In this zone is where inverse cosine is allowed. Where is cosine negative? Well, this is all students take calc. This is a place where cosine is positive, so it can't be there. This is another spot where cosine is positive, so it can't be there. So given all of that, do you get my triangle has to be right here? Because that's the only place where it's allowed. It's not allowed in here because this only goes from here to here, you know? Okay, so now I've got my triangle, and I'm going to say cosine is adjacent over hypotenuse. Adjacent side's -1, hypotenuse is 3. I don't have this triangle memorized, but am I going to end up needing the angle? Nope. At the end, I'm going to do sine of this, which means my answer is sides. Yes, I need that opposite side. I need this side right here. It's the square root of, and then do I do 3 squared plus -1 squared, or 3 squared minus -1 squared? Minus, because whenever they give you the two small sides, you would add them. But in this case, they've given me the big side, so I need to take the big side and subtract the other side squared. Okay, so there's how long that other side is. 3 squared is 9, minus 1 squared is 1. 9 minus 1 is 8, so that side is the square root of 8. Right there, that's square root of 8. And what's that? That's root 4 root 2. And what's that? 2 root 2. Yes, you always have to. You wouldn't want to leave root 8 as your answer. So root 8 turns into root 4 root 2. That turns into 2 root 2. So this side right there is 2 root 2. Okay, now all that work to now figure out sine. What is sine of this angle? Opposite over hypotenuse. Opposite side, 2 root 2. Over hypotenuse side, 3. There you go. That is the answer. Now, whether or not you should write, you could write sine of some angle is equal to that, but you don't need to. This is good enough to just, that's it. Okay, let's do one more on the back side. Any other nominations other than number 30? I'd like you to do that one yourself. Any other ones that look kind of weird on 20 through 30, 21 through 30? 25. All right. Read me number 25. Yep. Cosine with a little -1. 5/13. Okay. I know what's happening. They gave me two sides, and one of them's 5 and one of them's 13. I bet the other side is, it's a Pythagorean triple. Anybody recognize that one? 5, 12, 13 triangle, but we'll get to that. All right, so I'm going to go cosine of some angle is 5/13. They just gave me ka, adjacent and hypotenuse. I did that wrong. 3/13, sorry. Apparently we have the ravens in the crowd. Quoth the raven, nevermore. Quoth Mr. Server, please don't do that again. All right, anyway, ka is going to be 5 and 13. So I'm going to go like this and say cosine's only allowed here to here. So I'm crossing that off, crossing that off. Cosine's positive, so I must be here. Okay, now that I know that, adjacent 5, hypotenuse 13. Oh yeah, 5, 12, 13. I have it memorized. If you didn't, you'd have to say square root of 13 squared minus 5 squared. But guess what? It comes out to 12. Good Pythagorean triple to know. Okay, so now what? In the end, you want the tangent of this triangle now, or this angle, which is right here. And tangent of that angle is TOA, opposite over adjacent, which is 12 over 5, 12/5. Anybody beat me to that and had that already? Awesome. Good. Okay. I've given you a bunch. There's really not much new here. The only ones that are going to annoy you are the ones where it seems like you should be able to figure out the angle, but you can't. Like that problem we did at the beginning where we had, I can go back to it like this one, where it seems like they want you to figure out this angle, but you can't figure it out because you don't know any triangles that have sides of 1 and 4. You don't have to know the angle, though. In the end, on this kind of a problem, they just want the sine, which is just the opposite over the hypotenuse, which is 1/4. So there are times when these two just cancel and the answer is 1/4. Just be careful to always start on the inside so that if you do have something that's impossible, it stops the problem from working, you won't just be doomed by canceling these off. Don't just cancel those off. All right. And that's all I have for you for today. Got the rest of the time to work.